Hi everyone. My name's Edward Blanch, and my talk here is 8 years of technical art. Just to sort of give you a primer, I'm going to be moving probably relatively fast just through a whole bunch of techniques that I've used relatively regularly. I think potentially the way to get a vibe on what I'm talking about is more like some of these techniques are quite old, but still relatively applicable in what people are doing today. So it's just a bunch of like quick fire sort of techniques and examples of things that are really cool, as well as along with just like a general vibe on like some broader concepts that are worth sort of keeping in mind just about the way that you do your tech art and the way that you can model and whatnot that help for effects. I know some people have been to my talks before. They're going to be a little bits and pieces here and there that you've probably seen before. It'll still be strung together. There's definitely stuff in here there as well that I've not talked about before as well. So if you initially go into the talk and you're like, ooh, I've heard a couple of these, there are a few more coming up at the end that will show sort of interesting ways that you can think about doing things. Right, so like the basic thing that I always talk about whenever I talk about technical art is that art is the thing that actually gets shown on screen, but in the computer as well as in your art programs, in everything that you do, they are all the information for what's being drawn to the screen is stored just as a series of values with a series of values associated with it. When it gets handed into the engine, it's rasterized and it's constructed. And that's really important to remember because even though the values are being stored, those values don't have to make sense and they don't have to be accurate to what the values actually should be given that particular circumstance. And I'll give you some examples of that coming up. But it's important to remember that at the very basic level, the way things are working is that all your data is stored in a vertex. That vertex is storing that specific data. Then when you read it onto your screen, you're reading it as a series of 3 points and the averages of all of those pieces of data stored in those 3 points. So in this example that I'm giving up here, you can see that the vertex, the color, the fragment, basically if you have a blue, a green, and a red corner, the color of if you're using vertex colors in this sense, the color of the interpolated midpoint is the blend of those colors. The only reason why I say that is because it's important to remember that even though that's the information that's getting passed across, you're under no obligation to use it or treat it that way. So to talk about it straight out of the gate, these values are abstractions. This is one that I actually make a little bit of use of and it's really worth knowing. The normal is the angle that your vertex thinks that it's pointing. So the normal of your surface is the aggregate between the 3 points that are telling you which way that surface is pointing. So if I put that into the 3D program in order to light it, that's how it's able to detect whether or not my triangle is looking at my light source. But there is absolutely no reason why your normals have to be in the same plane as your actual surface. So you can reorient those normals in order for your geometry to light in a way that is completely different from that specific geometry. So in this particular example I'm giving here is by taking the basic normals that you have at your base vertexes where it's meeting the surface face, I'm pointing the normals directly upwards, which is that they have the same value as the surface face that it's going to be applied to. The reason why that's really useful is if you're doing procedural generation, it means that where that vertex meets that face, they will have exactly the same lighting information, which means that unless you've got ambient occlusion or something happening over there, you cannot see where the point of intersection is between that plane and that surface. And what it does is it creates the effect of a bevel going from one surface to the other. Same thing occurs in this particular example. By doing the same thing, as you can see down there on the bottom, pointing all my normals upwards, I can make a surface feature that's connected to the ground, in this case just like a weird sand lump, perfectly meet the surface that it's connected to. And then you can do a lot of like different and quite interesting tricks associated with that. And so on the right-hand side, there is an example of that same trick used in reference to doing foliage, which is that I can take the cutout shape of my foliage and I can take my normals and orient them to create the shell of what my tree shape is going to, how I want my tree shape to light. So you can say here, in the way that you want like a fluffy tree, you want it to light like it was 3 stacked circles, because we've got dozens and dozens of faceted, well, hundreds and thousands of faceted planes that together create the illusion of the shape of your tree. And contextually here, that's the way that you can do this sort of thing. But if you're doing procedural generation or a lot of situations where you're clipping a lot of different things together, it can be a very useful way to be able to modify your normal values in order to make sure that you can create those intersections without having to create the geometry to support those specific intersections. And that way you can get a lot of flexibility out of the model even before it comes in and even before you edit it. And this includes a lot of these values can be edited in engine as well when you're being able to modify it. So in your material or shader code, you will find that input normal is one of the values that you're able to read and then can modify in before outputting. So there are a lot of situations where you can actually be dynamically reorienting where a surface thinks it's facing on the fly as you need it. And then that gets rolled into the computation of your lighting algorithms. And this abstraction goes further. So in a lot of these cases, the way you think about a UV map is when you're literally UV mapping in your piece of software, you're thinking about where it's being positioned in a 2D plane, and that's how you do your unwrap. But that 2D plane is a value that's going from 0 to 1, from 0 to 1. If you think about that as 2 colors, red, no red to fully red, and then in your other channel, you're going from no green to the other channel. So that's what creates that UV map look here. So in this case, and I did it just in Substance Painter, created a stamp that was the exact mapping of a UV map, stamped it on the model, output it, and then you can read that in your material and use the colors from that texture as your input for your UV to be used by another material. You can go further. I didn't have this example drawn up because it was going to take a little bit longer to rebuild it in a way that I could show it easily. But this can actually be a really interesting way to do imposters in terms of being able to create an imposter that can take the material of something that that imposter isn't. Sounds a little bit confusing, but you can imagine in this context that if I have a character that looks like me, and instead of outputting my character's UV map, I actually take a front-facing photo of my character's UV colors and then apply that onto a flat plane and then use those colors to look into the same material that that character is looking in. You will get a transition of that. So you will see a little, and funnily enough, it's very similar to how deferred lighting works. So in this particular case, that customized UV panel that you have can be used to apply a material to it individually. And it can be a really powerful way of being able to simplify. But it is also important to remember that when you're doing a lot of these tricks, that your values that you're playing around with, they are representative of data. And so when things happen visually, that visual construction of it is crunching your data in a way that can be really negative. This is why often you'll hear artists say you can't paint UV maps, you can't blur and squish and squash whatever to your UV maps. And that's because your UV map is actually a vector pointing outwards from the surface. So if I have a vector pointing this way and I have a vector pointing this way, you can't blend them using paint tools. A blend of this and this does not equal 50% between those two values. So what you get is an incorrect value. And that can be quite hard to see. You can be painting them and thinking that it's working because you are getting something that doesn't look as harsh, but you are making that mistake. And in this particular example you can see, so this is the quite cool idea of having your own painted UV set. However, texture compression is a real issue. So when you get to the edge of your texture compression, you can see here that it blends to the black background on my texture. And it gives me a pixel that's halfway between that green value and halfway between black. That doesn't mean that there's 50% green. that is giving me the 2D coordinate of a different place in my texture map. So you can see in this example, what I get is a thin green line where the aliasing is occurring at the edge of the texture. And that is because you're using a data map and you're using an image compression on it that's going to cause a problem. In this case, that's where you can start to get really smart, and a trick that I use all the time, and why I'm mentioning this is because, right, so what we know here is we've got a compression artifact that we don't want, and it's making it hard. So how can I figure out where those compression artifacts are coming from? In this case, I do it by mixing in blue. I'm not using the blue channel, and the blue channel is hard up against my green channel, which means that if I'm getting blue values in my green valued channel, I know that that means that it's being blurred in as a consequence of the image compression, and I can discard that pixel, or I can remove an amount that's equal to how I want to be able to adjust it. And so what you're looking there is this idea of the thing that is negative can also help point you in the direction that is positive. So in this particular case, it's drawing in this value that I don't want, and because I only have two values here, 0 or 1, that I'm dealing with in this green value, I can't tell why and what's getting drawn in. And this actually also really applies to your baking software. So a really fun one is that a very old-fashioned technique is that a lot of people don't realize that normal maps and a lot of mapping technology is only actually storing relative information, not all information associated with it. Your details on the surface of your model do not need to actually be embedded in the surface. You can bake normal maps and ambient occlusion and a whole lot of other things with pieces of geometry that are floating meters in front of the surface that you need to bake it into, without constructing the complicated geometry that you need in order to do those insets. And it can work on quite complicated models so long as you know the part that you've extracted from it. In some cases, you will see artifacting come through as a consequence of it being double-sided. If you look inside your baking program, you will discover that it has an ignore backfacing. That's what this is for, by and large. There are other reasons why you don't want to pick up a backface in a lot of cases, like if you have a thin piece of cloth but in this particular case, if you turn off backfacing, it won't pick up the ambient occlusion associated with the face that's floating off the surface, but the ambient occlusion will exist within the surface that is floating above it. The only things that you'll really lose in that particular consequence are height maps coming off the surface, because it will pick up the height differential. Now, while you can't paint normals because they're a data channel, you can actually paint some things in your height map if you know the surface height of what you're projecting from. But there are dozens of other ways to very easily fix this problem, and one of which is that you can have different models that you bake for. Here's a detailed model, here's a different detailed model. But consequently here, this can actually be a really useful way to put high-level details in something that's otherwise going to be too complex. Another element that I think sort of goes hand in hand with this sort of type of baking is that I'm sure some people in here have used Substance. Do we have Substance Paint to users in here? If you're not using anchor points, start using anchor points. They are incredibly powerful, and you may or may not realize how powerful they can be. This is one of the things that I use more than almost anything else. You can create incredibly advanced brushes that can do very similar things to what I'm talking about by having anchor points as being used for essentially dynamic masking. So in this case, I have a height map or just a black and white map, and what you're doing is you're using the anchor point to pull different pieces of information out at each step. So even though I'm talking about shader stuff that runs dynamically in Engine, there's a ton of stuff that you can do in very similar ways in your Substance Painter, Substance Designer programs. This is actually just a really similar, I'm using it as a mask. I use it as a mask for the material. I blur it and use it as a height mask. This is an important thing to sort of remember when you're using direct masks to do height pop-ins and outs. It will create a normal pop-in, but the problem is if you're precisely, that is, it's like pulling in exactly vertically, you don't get the normal for the edge as it peels in, because remember, the normal doesn't tell you height information. So that perfect edge gives you less than a pixel to show the angle as it goes in. So you always want your height maps to have a little, if you're doing this in Substance, to have just enough beveling on the edge. Also because there's no such thing in the world as an absolutely perfectly sharp edge in terms of those details. But because it's an anchor point, I can just take it, blur it. Now I use it as a height mask. Do it again, invert it, the color of it, blur it, and subtract itself, and you get an AO associated with it. Do that same operation again, blur, remove the inverted, and then you get the edge of that, around the edge of that curve that you did. Apply a scratch filter to it, and you can do wearing and weathering right on the edges of where you've punched in your particular detail. Now, when I come to put the details in there, all I need to do is stamp in a height map stamp and just go boom, and it immediately creates the bump, the normal map for it. It creates the AO for what I just punched in. It can handle a height map, so you can see there, and like the fourth image, it doesn't have to be just a straight plug-in. The gear is actually a height map that's pumping in, and I'm adjusting my control layer so that you adjust the levels so that it has a harder edge for some elements and others when I'm doing my material masking. Really easy. Just another quick one, which is that for your own sanity, when you're building UV maps, it can be really tempting to try and fill holes and pack things as tightly as you can. Upwards is up, downwards is down, left is left, right is right, up is forwards, down is backwards. Don't twist your thing upside down because I can fit it in a hole better, because you will eventually be in your paint program trying to paint sideways and upside down and blend it between two corners. It can be really tempting to create the coolest normal, like the coolest matte baked components that you've ever seen in your life, and it will not be the trouble that it's worth. Secondary component is always, whenever you're doing mirrored UVs and things like that, and duplicate components, always make sure that you're offsetting your components by, in my case, just -1, so they're not in the 0 to 1 UV space. They won't get picked up by your baking program, and they will then just be pulling from the one that does bake. Secondarily, in this case as well, and that keeps you, sorry, I also failed to mention, that keeps your tangents correct in this particular context you can get when you're flipping and mirroring items. Another element that can be really useful in that I do when I'm doing substance painting and whatnot, you can sort of see here, I've put them all together. I tend to use external baking programs, and I'm going to tell everybody to use external baking programs in a second. But in my baking program, if I'm using several pieces that are constructing a whole, my separate pieces are put separately from the main model, but I also have a constructed version of it in the bake program with its offset UVs. That means when I bake it, I can see how the result of my bake is going to look on the whole of the model, even though the pieces need to be baked individually because they're otherwise going to be intersecting with those pieces. So I get the whole and I get the smaller part of it. Now, if you're using some of the better baking programs like Marmoset, you can actually specify that in the baking program as you're doing it, and that's one of the reasons why those are so much more powerful. If you're in Substance Painter and you're not doing it that way, then obviously you're not going to be able to get that level of sensitivity, so break your pieces out, put it together. So in this case, the insect's entire spine is made up of the same repeating piece, so it's baked separately. The tail and the head, which both aren't repeating pieces, those are baked in situ where they would be constructed on the model. And just make your stuff easy to use, because you're gonna go mad if it just is a nonsense thing. And the same thing sort of to a certain extent works if you want to construct complicated tiling textures. So obviously you can go in Substance and you can create really nice and powerful tiling textures. You can also actually, I suppose really the better way to describe this is that forced perspective and its equivalents work in video games as much as they work in real life. So that is to say, in this particular context, I can model an incredibly complicated surface, and the way that you may want to model it, or the way that I'm modeling it, is I instantiate it 9 times so that I can see myself breaking up the pattern so that you don't see the clear sides of my tiling texture. You're still going to get a certain amount of tiling, but it means it won't tile square, and as you move it, you'll see it shifting on all of them. Underneath that, 9 flat planes with the UVs arrayed around it, where only the center is going to be doing the baking. Part of the reason why you want to do that is because there is going to be a little bit of bleed and wrap around, and that will help make sure that you don't get any like tiny discontinuities. Bake out the high into the low, and you can get an incredibly complicated map that you can then paint up in Substance, you can then paint up in the software that you want, and you can get a surprisingly complicated map. And as we didn't have before, this is where things get really interesting. it's able to output quite an accurate height map to that complicated texture that you just created. That could be for rock work. In this case, it could be for rubble. There are a lot of engines now that do really interesting things with parallax mapping. They do really interesting things with occlusion-based height mapping and shadow-based normal mapping, which will be able to, even though it's all being stored in that texture information, you will be able to get a sense of depth. And remember, if it's rock or rubble, that height map doesn't necessarily have to exactly match the actual physical height of it. So in this case, it's nowhere near. It's like 1 centimeter bumped out, but you're looking at it from an angle that's causing you to look at it and think, oh, actually, that does sort of feel correct. Even though it's being squished, you're not necessarily going to perceive that, especially if this is the rubble on the side of the building in your skybox or in your other structured area. To that end, don't bake in Substance Painter. It's not good at it. There aren't the options that you need in order to do it. There are custom baking programs out there, use them. And some of them are free. Good old-fashioned XNormal is still there, it's available. It has the worst UI you've ever seen. Well, I don't know, it's not without its charm. Sort of, old audio player vibes, but it works. And it will give you a better result. And it gives you so many more options that you can toy and you can tweak and you can play with to get a better result. Nulled is one that I like. It works very quickly. It's very fast. I would argue probably the best is Marmoset. And it has the most tools to help you really tweak and get into what you're having. Often really where this will end up saving you a ton of time is on your shells around models that you're baking. So under like armpits and anywhere where you have complicated geometry, where you need to adjust how far out it's baking or how far in it's baking, which becomes a real problem in programs that have, oh, what's my in and my out value? Or I want you to supply me a separate shell. Huge problems, huge pain in the ass. Just saves so much time by just getting a decent baking program and just bake in that. And then bring your textures into Substance or whatever program you want. In the way that I talk about that all of this stuff is data, but can be turned into an image, all of these images are just data interpreted in the computer, this works in the opposite direction. It is a nightmare, often, to link different audio effects into visuals. But you can take your spectrum data, output it as a black and white map. Each of those lines is the actual spectrum. So like you would see in a thing going up and down as the amplitude of the waveform goes outwards. That is why it looks so bad. If you can see the first image there, that's why it looks so bad if you drive immediately into the direct waveform, because there are lots of cracks and empties there where there is, if I'm saying a word, that word and that sound shape are going to go through several valleys before it gets there. So one of the things that you can do is you can then take, let's say, your leveling tool for your actual, actual image leveling. That's the same process as audio leveling. Image editing and audio leveling and audio tools actually contain a lot of the similar structures here. So you can see the high point and the low point of the audio file that output the spectrum data. So you drag it and you get a much brighter version. Then you go through and you blur it. And it will begin to blur those centers together and you get this texture here. Now that texture, you may not realize it is the same as the original spectrum data, but it's been smoothed and evened out into something that will be a much closer approximation for what that noise is. So let's say hypothetically, you were trying to link the sound of like a boulder falling or something bouncing, and you wanted to link it to a texture. In this particular context, you could then choose how you want to use it. In my use case, you can just look up that information on your CPU. You just do it as a texture fetch without actually using the GPU on the process. In theory, you shouldn't really do that, but if you're only sampling 1 pixel in one texture, that's really not that expensive. It's just sampling through an array. And in these cases, these textures tend to be relatively small because you can shrink their size. You're outputting the spectrum data, but you don't want a spectrum data that consists of 1,000 points, because if you were animating, why would you want 1,000 points of animation in your animation timeline down to the most tiny fraction of a millisecond? Useless. So it's a really easy way to be able to do that. Also, in my experience, I find don't try to link audio to visuals. Try to link visuals to the audio. It sounds sort of like a counterintuitive way to think about it, but one of the things is you are never going to find an audio file that is, and you will find an audio and have really excellent audio editors, and this is what they do and that they are amazing at, but you will make their life easier. An audio file doesn't have the same clarity in the way that it works as some of the visual effects that you're trying to do. So rather than having a door close, and what you do is you go find an audio file and try to match it to the door closing, it can be way, way, way more beneficial to find your door closing audio first and set it up in such a way that your door closing animation is designed to match to the audio. Because if you think about it, I get an audio of a door closing, slam. What I want is when the slam point happens. And when I attach that to my door, I want my door to close in such a way that it'll hit at that slam point. And this, again, could be an example of where you could use spectrum data if you wanted to find where the exact closure point is by finding the highest pitch point. You could do it automatically. I would suggest designing an audio item holder for people so that when the audio people put the audio item in, they can stipulate it. Same thing works with doing slightly more like sort of wacky stuff in this particular context, right? So one of the things is that when you're very far away from something, you're not necessarily going to be as easily able to tell when something is animating in a really jerky manner. It's very easy to think that you want perfectly smooth 60 FPS, but if you have a bird that's flying across in the sky and you want it to look in a way that interacts with your scene effectively, you can do 3D particles. It's a bit difficult because the particle systems and whatnot aren't designed to do that. Here's a really way to do it. Take a really low poly random model that you found, put it into roughly a walk cycle of about 4 frames, stack them up on top of each other, create a second UV set where it's all packed into one spot, throw it in your particle editor so that it uses the second UV set to animate, and you wouldn't even need a particle editor, you could just do this in a shader. Every frame or every X number of frames at the speed that you want it to animate, it turns on one of the models and turns off the others, and then cycles through that in a loop. Then you just throw them out, have them point in the velocity that they're moving, and you've got a crowd sim. Want to move them around? Add in a particle effector, and they'll begin to move and avoid obstacles and all move together in big crowds. And obviously, it's as expensive as rendering as many of your low poly model. And here, I've actually got it more polys than it needs. I could have way dialed it down. I could have gone way further. I could have made it so the shirt color depends on the particle color, or the hair color or skin color, and do that in such a way that you can create it so that it would generate a much greater variety of different people in the crowd, rather than just the same plaid shirt wearing polygon man. Another trick I use all the time, try planar texturing. Really get into it. It is like save you 1,000,000 hours in level design, and if you're not doing level design directly, your level designers will help. In this, it will make them very happy with you. In this case, I just quickly threw it together to create a drawn art style using Unreal post-effect materials. And in this case, actually built it really simply. It doesn't look simple, but the node graph is a little bit complicated for it. But really all I'm doing is I'm saying, hey, give me the world position of my fragment, single node that gets that. Then I want to say, hey, I want to create a set of UV coordinates for that. So X and Y would be, the height and the width of my world. So there I've got one. But sometimes my surfaces are facing different directions. This is a circumstance where you want to go, all right, if my surface is facing that direction, I want X and Y to be texture. If it's facing that direction, I want X and Z, or Y and Z. And if it's this direction on flat, I want X and Y. And then I just want to blend based on what that is. Boom, really quickly, set it up, put in a hatch pattern, took the lighting, took my main color, subtracted the main color from the lighting just to get my lighting, output the main color as a black and white, applied the lighting, instead of applying the lighting, apply the lighting through the hatch pattern, apply that onto it, output it, and I also threw in a Sobel filter over the top just so that it would provide edging for things based on the depth map. And you can get a stylized effect really quickly. I wasn't going to go any further with this. There's a ton of stuff that I could do to make it look better. That was literally, all right, half an hour, let's see what I can do. That is a really wacky interpretation of why triplanering is useful, but think about it from the perspective of like your level artists. It can be really useful to provide them a triplanar material that can just have brickwork on it, or concrete, or sand, or dirt, and what it means is that they can bring in a model that has no UV coordinates, it has no textures, they can take a standard cube, they can stick it in the world and throw the material on it, and it will immediately just texture it, make it the right height, the scale for everything. They don't want to use it because they want to build a big complex level. They want to use it because there's a gap between these two models and they need to fill it quickly with just a piece of concrete or a piece of rock, or they need a brickwork facade to just quickly go in there and throw something on. You want to give them that tool because it will save them 1,000 million hours. And part of triplanar mapping is to really get comfortable with what a dot product is, which is dotting two vectors. So dotting vectors gives you a value from 1 to -1 based on whether or not the vectors are pointing each other or pointing away. I'm sure a lot of people know or should know what this process is if you're doing shaders because they use it for lighting. But basically, go in, look at dot product, you really want to use it because what it means is it allows you to be able to tell when surfaces and surface angles are looking at each other or looking away from each other, because there's so much you can do with that information. In this case, for triplanar mapping, that's how I can tell which UV set that I want to use for which surface direction is it pointing in. Because I know, because we're in a linear coordinate system, I know that in my vector of directions, 1 is a single unit vector, it has no magnitude, so that means if I've got x, y, z, a value of 1, 0, 0, means that we have one vector in the x, which means that's pointing forwards in the x. Really simple. And if I'm doing a dot product, I can say dot product between 1, 0, 0 and the normal of my surface, and that will tell me, is it facing towards my surface, or is it facing opposite from the surface, or is it facing 90 degrees to the surface? So if I'm creating a triplanar formula, boom, I just want to blend it to whichever surface they're the closest to, and that's the one that I want to use. And then you can adjust your tightness and your softness of your blend based on what percentage towards that surface is it. Really easy stuff to build. But you can take it to do really interesting things. So here's a really interesting example of faking a degree of volumetric fog. This is actually the same pile of planes. The one on the right is fading out my particle as the surface of my fog becomes flat to the camera, and it changes the alpha value. And you want to do that because as your flat surface plane comes to the camera here, it begins to over-occlude on top of each other. So instead of getting a nice cloud that I can see through, I start to get a more and more strong white line as it goes completely 90 degrees to the camera. So as you can see here on the left, as I rotate around, you can see all these ugly, really clearly see all of the different ugly planes that make up this cloud. And if you look on the right, you can't see where those planes are. And because of your inability to see the planes, it looks volumetric. It looks like a cloud that has volume, when in reality, it's about a half a dozen planes all thrown together. And you can get some really quick and easy techniques and tricks out of doing stuff like that. So if you go into there, this is just how you can build it relatively easy. So you can see in here, I've gone a little bit more complicated. You could just do it with the angle of the surface itself. I've created just a custom one which basically says, hey, where's the camera? Where's the position of my surface in the world? And then I want to subtract. This is how you get a vector. Subtract one from the other, normalize. That gets me the vector pointing from the camera to that pixel on the surface. And then I want to dot between those two values. Then I want to absolute that dot because basically it goes from -1 to 1, but I only want values I want values to go away that are halfway between that. So -1 I want, because that means it's double, if I want my particle to be double-sided, which I do, I want -1 to be 1, because if it's facing that way, I want to see it. If it's facing that way, I want to see it. And if it's facing that way, I don't want to see it. And then what I do is I absolute it, so it goes 1, 0, 1. Run it through a power function, really simple. That just means that I'm adjusting the amount and the way that it's going to fall off as it turns. Final step, I just threw in a depth fade just so that you don't see it clipping hard into the surface of that. And there's just straight up a material node that will just do that for you. Not hard to do if you don't have that node. You basically just get the depth of the pixel, your depth map and then you fade it the closer those two are together. So similar thing goes for if you want to do interesting things with height maps. So this is another interesting version of sort of the same technique, which is that parallax offset mapping, very old-fashioned technique. I use it a lot. There is a single, again, node in Unreal, which is called bump offset. Super easy to use. Takes a height map, takes a UV map, and outputs a UV coordinate that has been adjusted by the angle that I'm looking at it. By doing that, what you do get is it just changes where it's sampling from to create that illusion of height. But you can animate that. There is no reason why your height map needs to be static. So in this case, if I just throw a noise map across my cloth and do it with the height, it creates sort of an artificial flickering. If you add that in with a dynamic wind so that it's flapping, you will get sub-wind flapping that exists where there is no geometry in order to create that bend or that flapping associated with it. Same thing again goes with like this weird tiling bouncing ground where it's just like I've just gone in and I've said, hey, I want to mumble. So you could see a really simple way of doing this. Let's say you're doing like an earthquake in your game, or you want some things to, you know, when something pounds on the ground, you want to see everything move. You can take the height map of everything that isn't like your flat ground, and then you could just jiggle it a little bit by just upping the height a little bit. You will get a little bit of artifacting, because as you push those UVs and go really off askew with them by pushing it really strongly, it will start to sample from outside of where you might expect it to. And for things like tiling tiles or whatnot, you'll begin to grab texture information from the adjacent tile, and it'll look, so you can't push it that much, but you can push it subtly enough that it tricks your eyes into going, huh, it does actually weirdly look like those panels are all bubbling up and down, even though there is actually no UVs or texture movements associated with it. So how am I going for time? Because I do want to give people a chance to ask questions, because I never ever give people a chance to ask questions, because I have shot through it pretty quickly. So yeah, really the big thing here is that like some of these are very old techniques, right? Like they're not particularly new or even particularly modern, but there's probably a pervading frustration of mine, which is that we always shoot directly for the absolute most advanced level of technique sometimes when we're looking to do things, and that can be especially difficult because like, you've got a parallax offset height. There are more complicated versions of this formula which are doing like ray casting into your surface. There's literally, you know, height map notes in Unreal and Unity that are specifically designed to create that sort of effect where you can see real depth, and it creates, you know, or geometry where you actually split the geometry up into sub pieces and you move them. And there are so many circumstances where you just don't need to go that far. These cost about a fraction of what those big expensive techniques were, and will get you 90% of the way there for all of the little effects that you want to do, all of the little things. And so it can be really tempting to just fly straight for, right, I'm going to make a model. It's going to be 10 million polygons. It's going to be carefully sculpted to have those joins. It's going to have a, you know, I'm going to put a complicated cloth, I'm going to make a complicated cloth sim so it flaps in the wind, and I'm going to make it so that you can see the pistons moving slightly, and I'm going to do it all this way. Every single one of the techniques I just talked about can be done using these techniques without actually having to go immediately to the top drawer of the most expensive, the most advanced rendering techniques that are out there, when a lot of this stuff just gets authored with the texture, gets authored with the model as you build it. You can put it together, you can get it out there really quickly. A side thing to remember about the height map stuff that we're seeing here, if anybody's working in VR, it works very well in VR. Because both eyes are giving you a slight offset, you are getting artificial depth from it. In fact, it works better in VR than it works in your flat application. Because your eyes are seeing two slightly different versions, you are getting depth information there that otherwise wouldn't be coming through. So it very unexpectedly works in VR in a way that you wouldn't imagine. Only thing to be careful with a technique like this one is that it is using something which tends to be called a dependent texture fetch. So that means before I can use the UV, so that's what you can see this node doing here, right? So it says height and coordinate. So it's taking a UV coordinate and it's taking a height map. This means that it has to get the value of the height map before you can get the value of your normal, your whatever other textures, right? What that does in the GPU is it creates sort of a little mini queue. That is, I need to fetch my height map before I can fetch my texture map or my normal map. And it's very tempting when you're going absolutely ham on this texture map looks up into this texture map, which looks up into that texture map that uses this texture to do that, which uses this to use that. And what you're doing is you're creating this big long chain, and that can actually create quite poor performance in a lot of circumstances because it can't. The GPU does a lot of optimizations. Quite frequently, it can do multiple texture fetches at the same time. So basically, it's going, I'm getting the normal and the thing and this and this and this, and we're sort of doing them all in parallel. But now that I have to wait to get this result first, I can't do this in parallel. There's a lot of optimizations that go in GPUs that are really interesting that some of this stuff can trip in. And Unreal's material editor is really awesome, but be careful because it's very easy to accidentally just way overload your shader with all of this stuff and place them behind each other, and you will end up sort of overloading it a little bit and will not be immediately aware of like, oh, this has got 4 texture fetches in here and is running so much slowly than this one that has 30. And it can be because 30 can happen as fast as 1 if the GPU and if the algorithm is able to pack it in such a way that it's doing the 30 at once. But whereas you're going, I have to do this one and then get the information back so I can do that one, so I can do that one, so I can do that one, and it's doing that in the hardware. Right. I know that was a lot to take in. I powered through it. Do we have any questions that people would like to ask while we've got time here? I think, do we need to bring the mic around was the suggestion? Sorry, I've been instructed that I would just shout, but I've been instructed that a mic must be used, so. And I believe I saw a hand there. It's my first question.
All right. One thing I'd be like, I normally don't. I do a lot of tech art and stuff and art in my project, and like I'm not really great. I've been using Substance's Baker.
Oh, I'm gonna. No, I'm sorry.
I've got Marmoset. I'm just lazy.
Yeah, that's legit.
But I did recently have to use Marmoset because like Substance wouldn't work properly. But anyway, the question I had is like, in my game I've got like a bunch of characters with the same models, but with like different skins. Just for like picking a different skin, it's like a fighting game.
Yeah.
The models are identical, but the skins are different. And I'm wondering, have you ever like encountered this and had like a way of doing the workflow? Because right now I just have like I have like a bunch of folders in Substance, one for each skin, and then manually export all of them by turning them on and off. I'm wondering if there's like, is there an automation workflow you could recommend to like make that whole process a lot easier?
I suppose it depends on how complicated and different your skin is, right? So really one of the things that you're going to run into is like when you're doing Substance is great, but as you've probably already correctly flagged, it's not great at being able to do those sort of automation tasks. Frequently, I just use a separate Substance file for them and use smart materials to carry a lot of stuff through and have my base map set up. So if I've got one character that's going to have like X number of different skins, I will do things where my like material zones for those skins are actually a separately rendered element that is then brought in for each of the files. Because then what I can do is I can change, that is then stored externally. Because then it's like, okay, so if I need to make a modeling change, then I can change like this component, like the easiest way to describe it is like, okay, I'm using a lot of these generated mask maps in order to do it. So if I do have to change my UVs, if I'm using mask mapping more so and I had to change the character model, I can re-import my mask maps and I have a closer, better chance of my materials then reapplying if I had to do a change. I know that doesn't answer exactly your question, but not really. I know what you want to do, and I've looked, unless somebody else here knows, I've never found a way. I know what you want to do, which is you want to have one file that has several materials in it. One way that I have done it, and that we have done it previously at one of the companies that I worked for, is get one file and bring that model in 5 or 6 times, right?
Oh, right, yeah.
Next to each other in a line. And then you texture each one with a separate, and it's got a separate material. Boom, 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 boom. Texture it, texture it, texture it, texture it, texture it. And then when you click export, you will go, it will spin.
That are sort of different texture sets, basically.
Yeah, exactly.
All right, that's
so one
probably
model, 5 models. Problem is, be careful, that will get very unstable at a certain level. Once you've got above 5 textures, things like 5 models with like, if they've got several materials and textures on them, it will really become a big, heavy substance file.
Yeah, I don't plan to have that many materials, so it might be all right.
So that'd be the way that I'd do it in the easiest.
All right, thank you.
Questions more? Oh, there we are.
Hey, so not really about any of it is, but like
anything.
I just walked in here and I missed most of this, and I'm spewing that I didn't. The bits that I did see, I thought, I should have been in here earlier.
No, that's right.
Is this being recorded? Are we able to?
I think so, to my knowledge, yeah. So you should
Okay.
be able to pick it up.
Brilliant, thank you.
Yeah, no, all good. I feel your pain. I've had that happen.
Anyone else?
Yeah, we've got a question over here.
Thank you. You mentioned the queuing that would occur if you have a bump map or a parallel exclusion map or something before you're like editing your UVs before you actually utilize them. I'm in the habit of packing height maps and displacement maps into, with the occlusion and the roughness maps in like an ORM texture. If I'm using a bump offset or a POM, should I have that as a standalone texture? As like a grayscale compression, so it's a bit smaller, or am I?
No, you're doing it the right way. The reason why packing is useful is it will pull it into, that's more of a memory thing. It only needs to pull one texture into memory, and then it samples it. So you're still getting the benefit. You may not realize it, but basically what happens is, if I'm sampling this texture and then sampling that texture again, based on the results of that texture, I'm still having to go that operation, but I've only loaded that texture once. It's gone into memory, and then I've done 2 samples into it. I haven't gone in and put it in 2 completely separate places in memory, and then I'm sampling there and there. So you will find actually that you're getting an efficiency doing it by doing it that way. It's only pulling it in once. So yeah, if you can pack your textures together, it doesn't always need to be done, but it's a worthwhile thing to do. Like there's a reason why textures get packed. And when you get real heavy, and to a certain degree, unless you're using special formats, you're sort of paying for that extra space anyway. On more powerful systems, like, you really have to be spamming it. And I mean, everybody's seen the number of texture maps Unreal throws at some of their higher level models. So it's like, clearly there are ways to get around that bottleneck. But yes, if you're packing them, you're doing the right thing. Questions anymore? Oh no. This is going to be a hard one. I'm teasing.
Ed, what do you think about packing your transparent map or your alpha transparency into a different mask map aside from your color map?
Really interesting. There's a lot you can do with that. The main reason why I would do it, and here's a really interesting one. If you've got a mask map, like a black and white hard mask map, actually make it a signed distance field mask map. Don't make it a hard mask. I sort of had a slide that I was going to do in this one, but there just wasn't time to get through it. But a mask map, if you're trying to cut something out, is a white and a black mask. So we all know how that works. However, go into Photoshop, go like outer glow, set it to white or dark, depending on which direction you're going in, and then set it to linear, set it to hard, and you'll get a gradient that goes from light to dark. Then what you want to do is select the point in that gradient that you want your edge condition to be. Now the reason why that's so powerful is that you can set it up so that if you're anti-aliasing or whatnot, so one of the reasons why you get aliasing artifacts a lot, especially when you're using clip textures, is because it flicks across here, we're at 0. Flicks across a pixel there, you're at 1. Flicks there, 0, flicks there, 1. If you've got a signed distance field with it, it's getting closer to 1, closer, now it's 0. Getting closer that way, now it's 0. So as you're doing those little movements, it's ironing out a lot of your jaggies associated with it. In terms of it, it's actually interesting because technically, in terms of actually then packing that into your texture map, packing your alpha into your texture map, I think it's worthwhile separating it. And I think it's worthwhile separating it is because it's going to make it easier for you to edit. Having to edit it in Photoshop in the existing alpha channel is a nightmare. It gets worse if you export it as a PNG because it will destroy the other channels as it comes through. So if I'm honest, I would say that I do tend to do them separately rather than packed in, excepting in circumstances where, for whatever reason, it's an existing, somebody else's existing setup that wants that as the input. But yeah, I would say separate it out. You will have a much nicer time. There is other useful information that you can pack into the alpha channel of your texture if you want. I don't know if you would agree with that approach, but yeah, that would be, ultimately that would be my approach. It's going to be easier to edit, and the cost is really going to be negligible ultimately. And you could pack, and the nice thing that you could do with that is that now that theoretically you've got more channels that you could potentially use. So if you want that, you can now pack a few more different for that alpha clip that you want to put in there and then use them more effectively, and there's a lot more you could do with that. Any more questions? Anyone else? Oh, one in the back. Ooh. Had my own timer telling me I was going to.
So you covered a lot of really cool stuff. I'm curious though, like, is there any like really out there techniques that like you personally think are really cool that you'd like to see done more often, or just because they're really?
I love the fact that Unreal stores a sign distance field for the entirety of your world, and they badly underutilize it. That information is unbelievably powerful. With one caveat, I think it actually produces not a very good AO. Right? I think it's a substandard AO equivalent, which is what it typically gets used for slightly more accurate, because you can see the sign distance AO, because basically what it does is, so if anybody doesn't know what sign distance fields are, basically a sign distance field is a data structure or texture or whatever you want it to be, where each pixel doesn't represent in or out, it represents distance to the edge. And a sign distance field means it goes from -1 to 1. So it just means, am I inside or am I outside the object? So the reason why what Unreal is doing there that's really interesting, and that other programs are now starting to do, is they do it in 3D. So that means at any point on a texture or in a world, I can ask, how far away am I from another surface? There is so much that you can do with that, and that's also where all those really interesting ray casting optimization comes through. You can do stuff associated with like wind calculation and audio leveling, because you can basically be like, whoa, how tight are we? How wide are we at this particular point when I'm doing things? And you can blend between distance fields. There's a lot of really interesting stuff you can do if you have access to that data and you can use it. They are really powerful. So I'm not sure if that's wacky. It's just one of those things that now that we're getting powerful enough is becoming much more common and usable, and even in some cases becoming dynamic. They're very heavyweight to generate. But the fact that it's just there and it exists and it's being constructed as part of your world construction, there are so many cool and interesting shaders that you could do and visual effects that you can do as a consequence of that sort of thing. In terms of like weird and wacky techniques, it's more in terms of like you can get really bizarre effects when you start switching streams and stuff, where like vertex information starts getting garbled out the other end, and I've seen some really interesting versions of that where it's like just an unexpected way to think about how you could create certain types of visual effects, where you're like, it's sort of, you take it from the normal version but you go even further than that, where you're like, it's using data in a really unexpected way, where like, I'm modifying my vertex data using a texture to create a vertex data out the other end that doesn't represent a mesh or a model whatsoever. And I'm using that in a really unusual way. And I have seen some people do very strange things online with those sorts of effects. But no, the sign distance fields I think is something that we're going to be seeing more of. Especially I think a lot of people have been, I don't know how many people have been following like neural radiance fields and things of that nature. I think that will be also a really powerful and really interesting way of being able to do things. I don't think we'll ever see a video game done, or not yet done entirely in it. Aside from some of the performance implications, just the way that it works doesn't necessarily work 100% within the way that we would like to do things. But I can certainly see the ability to merge neural radiance fields intersecting with actual generated geometry and stuff that we're building. It would be really interesting to see where that goes. So I'm really hopeful that that gets better. And as the hardware gets built in order to take advantage of that, I think that that's, for instance, like I think that's going to be a bigger deal than like ray casting and ray tracing and whatnot going forwards, honestly. it'll be a bigger deal. But I'm wrong a lot, so. I mean, when done in combination with ray tracing and ray casting and whatnot for more classical techniques, I think we'll see some really cool stuff. But yeah, neural radiance fields store a lot of really interesting information in them that goes way beyond just the shape of the object, which is pretty cool. Oh, I think we're done. Yeah, thank you.